What you see right now is what we call stars, and these stars undergo stellar evolution, a process by which a star changes over the course of time. Now, let me ask you a question. Have you ever wondered how the star is born and die? If it's not, listen and we will discuss all about the stellar evolution. In this lesson, we will discuss how the stars form and develop over time, including the less massive stars and more massive stars, as well as on astronomical concepts such as stellar birth, stellar nurseries, stellar life, star death, and stellar evolution. Just like people, the stars are born and eventually die. And so, we will start with the stellar birth. Stellar birth refers to the stars being born. In space, there is a huge cloud of gas and dust called nebula or molecular clouds. And always remember that all stars start from this. This nebula is mainly composed of hydrogen, and gravity is the one that holds the particles of molecular clouds. What the gravity will do is that it will slowly pulse the gas and dust together into a huge rotating ball. At this point, the relationship between the pressure, density, and temperature will influence the interstellar medium. When this three increases, no heat will escape from molecular clouds, and this will result into the formation of protostar, an object that has not undergone nuclear fusion. But what is nuclear fusion? Nuclear fusion is a process where the hydrogen atoms combine together to make helium atoms. In other words, it is a process used by the stars to create their own energy. Now, what will happen if this protostar undergo nuclear fusion or when it reaches the temperature of 10 million Kelvin? When this happens, the star is born. And inside of every newborn star, hydrogen atoms are fused together to make helium, and it creates the energy of the star and make it shine. After they are born, their fate and what will be the life of a star will depend on how massive the star is from the time of its birth. Meaning, each of them will lead a different life based on their mass. Stars may become a low-mass stars and high-mass stars. A star that has a lot of mass may end their lives as a black hole or neutron stars, and low-mass stars will become a white dwarf stars. To understand more deeply the low-mass stars, it's necessary to tackle first the planetary nebula. What you see right now is an image of the planetary nebula. The term planetary nebula was coined by astronomer William Herschel in 1780s. He called it planetary nebula because he noticed its round shape that reminds him the planet. So this is created when a shell of gas is ejected by a star and illuminated by its central cold white dwarf. We all know that stars undergo nuclear fusion because they need it to create their own energy. And to do that, there should be a fusing of hydrogen to create helium. But at some point, the hydrogen of low-mass stars will start to run out, and so the nuclear fusion will stop, and this will result into an explosive flash that leads to the formation of red giant stars. The red giant will be eating helium to live, but when the helium runs out again, the helium will ignite and the outer layer of the stars are blown off in a huge clouds of gas and dust called planetary nebula. And the only thing that will remain during this collapse will be its core called white dwarf. The planetary nebula is only visible tens of thousands of years, and once the white dwarf cools and fades, both the planetary nebula or white dwarf will not be visible. Remember that the nebula and planetary nebula are different because nebula refers to a region where the stars are formed, while planetary nebula is a special type of nebula made when the outer layers of an old giant stars are thrown off into space. Now, we will proceed to nova, novae, and supernova. The word nova comes from the Latin word for new. The plural word for nova is novae, and it can brighten as much as 100,000 suns. Low-mass stars end its life as a white dwarf star, and these white dwarf stars do not disappear quietly, and so, at the end of its life, a white dwarf will steal gas from its companion star. With this, an explosion that will make the stars to shine brightly up to 1,000,000 times than the normal will happen, and this is what we call the nova. This explosion will take place repeatedly as long as it continues to take the gas from its companion star. The supernova and nova are almost similar in some aspects because they are both characterized by a rapid brightening that lasts for a few weeks in the galaxy. But don't be confused with that, because nova is an explosion that will make the stars to shine brightly, but the supernova ends the life of the star. And now, we will proceed to the supernova. When there is no energy that can be got from fusion, the star will collapse, and after a second, a violent explosion will happen that can outshine brightly the entire galaxy, and this is what we call the supernova. When this happens, it marks the death of the star. Since it is a violent explosion, it releases a big amount of energy. Supernova explosions not only release radio waves and X-rays, but also cosmic rays, the brightest and fastest radio blast ever seen on the sky. The supernova has two types, the Type 1 supernova and the Type 2 supernova. The Type 1 supernova is a type of supernova that low-mass stars undergo. It happens when a white dwarf steals hot gas from its companion star. Then, the Type 2 supernova is the final stage of the evolution of the star called high-mass stars. When high-mass stars can no longer produce a nuclear energy, it will collapse to form a neutron star or black hole. Now that we're done with the low-mass stars, it's time to know that some stars are more massive than the Sun, and they lead a very different lives, and they are called high-mass stars. They have a greater mass, but they will not live longer because they can just live up to 10 million years, compared to low-mass stars that has 10 to 50 billion years. Its characteristics include very high core temperatures, it is also very big and bright, and ends its stellar life with a bang. Unlike the low-mass stars that can only fuse hydrogen and helium, it has the ability to fuse heavier elements like carbon, nitrogen, and oxygen, and this is the reason why this star gets bigger and bigger. After a million years, and when there is no more energy that can be got from fusion, the core will collapse and the rest of the star. After that, the outer part of the star will blasted off and will result into supernova explosion. It is so powerful that when one of the stars explode, it can actually outshine the whole galaxy, and the energy and particles released by the supernova is very dangerous on life on Earth. The only thing that will remain after this explosion is the core of the heavy stars called neutron stars. Just like what I have said earlier, when a massive star runs out of fuel, it will no longer be able to produce sufficient energy to maintain its structure, and so it will collapse and explodes in supernova, and what leaves behind is what we call the neutron stars. In other words, when the high-mass stars is at the end of its life, it will become a neutron stars. Neutron star is a sphere of neutrons that is created by the collapse of the iron core, and the concept of neutron stars was first proposed by Walter Baade and Fritz Zwicky. It is composed of neutrons, and it is also very hot. It spins rapidly that it rotates 700 times every second, and that's how fast the spinning of the neutron star is. There are two objects related to neutron stars: binary neutron stars and pulsars. Binary neutron stars are two neutron stars orbiting each other, while the pulsars are a rotating radius source and a type of neutron stars. A neutron star radiates beams which appear to blink when viewed from Earth, and this is what we call the pulsars. Now, let's proceed to the neutron stars and companion star scenario. After a billion years, the rotation of neutron stars will start to slow, and so it will start to disappear, but not all will disappear quietly. Just like the white dwarf stars, the neutron star will steal gas from its companion star, and this will form an accretion disk before collapsing into a black hole. When we say accretion disk, it is a disk-like flow of gas around any astronomical objects. The reason why this happens is because enough gas builds up on the surface of the neutron stars. This scenario will produce energy called X-rays. Neutron star is much hotter than the white dwarf, and so neutron stars are a powerful X-ray source. That's why it is also called as X-ray binary. This type of objects that emits bursts of energy are called X-ray bursters. And this is the end of life of the high-mass stars. Now, we will proceed to the GRBs or the gamma ray burst. One example of nuclear weapon is atomic bomb, and these nuclear weapons are tested in space. Because of that, United States developed a satellite that will monitor gamma radiation emitted by nuclear weapon. With this, they also observed that the gamma radiation outburst that comes from the space is released during the supernova and also made by neutron stars, pulsars, and black holes. Gamma ray bursts are flashes of gamma radiation related to extreme energetic explosions detected in a very distant galaxies, and also the brightest electromagnetic events occur in the universe. They also lasted from 10 milliseconds to several minutes. Many satellites are built to observe GRBs, and one of these is Compton Gamma Ray Observatory, a satellite that determined GRBs. Astronomers wanted to study the gamma ray burst because it provides information about objects such as active galaxies and pulsars, and be able to see how violent events like supernova can shape the universe. Stars live for a billion of years, and our lives as a human is just a blink of an eye if we will compare it to the stars. Just like people, stars are being born and die. And studying the stellar evolution, or how the stars develop and form, allows us to understand where the X-rays and gamma rays come from. That has a lot of purposes when it is being used appropriately in science.